Hello, welcome to all. Okay, today let us try to understand the magic of boiling and melting of a substance. The most common substance in our daily life is water. What are the three states of water? One is which we are all familiar with is the liquid state itself, which we call it as a water. And what is the gaseous phase of water? It is a water vapor. Next, what is the solid state of water? That is the ice. This important process from the point of view of physics is the state change or the phase change. Okay, here the material is transforming from liquid state to state and solid state to liquid state. Okay, so our water is able to present in all the three forms. Depending upon the situation, it can exist in all the three forms. Okay, here you may also see a point where you can see all these states together. Okay, that is a different thing. We call that as a triple point. Okay, at one particular temperature and pressure, you will see all the phases together. That is another interesting story. Okay, first of all, just let us try to understand what happens when water boils and what happens when ice starts melting. Okay, when do we see the phase change from liquid to gaseous state, vapor state? Okay, as you go on heating, what happens here? These are all the thermodynamical processes. Okay, here the vaporization, that means transforming material from liquid to gas. Okay, this is, we call this as a vaporization. This is a thermodynamical process. Similarly, we may transform the ice into water. Okay, this is also a thermodynamical process. See, here some interesting thing happen when water starts boiling. That means when the phase change takes place from liquid state to vapor state. So when do we observe this state change? Okay, what we have to do basically in order to change the phase of a substance? What we will do generally, see, whenever we start heating the water, that means what is the meaning of that? We are pumping the heat into the system. What we naturally see is, as we go on heating the substance, the temperature, what happens here? Yeah, here you see, here I am supplying heat to the system. Okay, I am pumping some heat into the system. Now what is our system? It is just a water in a vessel. So as you go on heating the substance, what happens here? The temperature, small t or capital T, the temperature of the substance, goes on increasing. This water goes on increasing. Okay, as you put one thermometer here, okay, and observe the change in the temperature, Okay, as you go on heating, see, here you will see the increase in the reading of this thermometer. That means the temperature of the water is increasing. How long this happen? We have to see how long this increase happen. See, after some time, that means we call that particular point. See, whenever the temperature of the water reaches to a particular value, okay, then what happens here? We call that point as a boiling point of the water. See, at that temperature, water starts boiling. So what happens here? It transforms into vapor at one particular temperature. We call that point as a boiling temperature. See here, see as this process just started, what happens here is, even though you are pumping the heat into the system, the temperature of this environment does not change. Okay, the temperature will be the same, the temperature of the substance will be same. But so far what we have seen, just rise in the temperature as the time goes on, as we go on pumping the heat into the system. Okay, we observed that the temperature of the system is going up, but whenever this temperature reaches to the boiling point of the water, what happens is you never see any further rise in the temperature of this water. Okay, any further rise in the temperature of this water. Here what you are doing is, at this particular temperature, boiling point of water, okay, you are transforming the liquid into the vapor. Okay, both are at the boiling point of the water. Okay, that's why we are giving some special name for one particular temperature, what is a boiling point. That means whenever the temperature reaches to that point, that value of the temperature of the system, okay, either the water or vapor, does not change. How long it goes on, you will see for a certain time the constancy in the temperature. This is what the magic of boiling. Why? Because generally we expect some rise in temperature, okay, as we go on pumping the heat into the system. Okay, it happens for some time, but whenever the process of conversion of liquid into vapor just starts in, then what happens, from then on the temperature of the system, okay, this water does not change even though you are continuously pumping the heat into the system. Yeah, that is what the magic of state change or phase change. Here the phase change of matter is taking place. So water is changing from liquid phase to the vapor phase. Okay, when do you observe the rise in the temperature? See, it happens only after complete transformation of water into the vapor. Okay, suppose that this entire water is converted into the stream, then what happens? The temperature of this stream goes on increasing. That means, are you observing any violation of law of conservation of energy here? No. But here the law of conservation of energy is perfectly applicable for this system. How it is possible? Where that heat content is going on, here the system is utilizing, okay, that heat content for doing the work of phase change. Okay, it has to do some work to go from liquid state to vapor state. Okay, that work is being done by the heat you are supplying since the system's temperature reached the boiling point. Okay, this is what the thing takes place, okay, in the process of boiling of water. Okay, this is what the magic. Here it is not in contradiction with the law of conservation of energy. So what we have to note here is, as long as one statement we have to make here. What is the statement? As long as the phase change takes place, okay, there is no change in the temperature. There is no change in the temperature. Okay. Here, what is our conclusion? As long as the process of state change takes place, the temperature of the system remains constant. Okay, that is what the importance of boiling point. That means we are giving some special name for that one particular temperature. Why? Because it is special in the sense that you are going to see the same temperature for the long time. That means as long as the state change takes place. Once this entire water is converted into the entire steam, then what happens? Until then there is no scope for doing some other work. So the entire heat is utilized by the system for its for the rise in its internal energy, that means the temperature. From then on, the temperature of the steam goes on increasing as you go on pumping the heat. Okay, so far we have studied only one process of phase change or state change, that is from liquid phase to gaseous phase. Okay, water to water vapor. Okay, next let us see what happens when ice melts. That means when water from solid state to, here the water is changing from its solid phase to liquid phase. Okay, now we are getting water out of the ice, out of the expanse of the ice. This is also one thermodynamical process. Okay, here in this liquefaction process, what is happening here? The same thing which is similar to this takes place there also. Here, when do you observe the melting of the ice? Okay, when do you observe the melting of the ice? See, when the temperature of the ice reaches to its melting point value, okay, from then on you will see the transformation of the ice, okay, the process of transformation of the ice into water. Okay, suppose that the ice is at very low temperature, that means in minus temperatures below 0 degrees Celsius. Okay, then what happens? There is no question of liquefaction. Okay, it stays in the solid state only. So whenever you are coming up to 0, okay, and then suppose that you are pumping the heat, then also, then what happens here? The process of liquefaction takes place, liquefaction of the ice takes place. So from then on, suppose that the ice is at some sub-zero temperatures, okay, in minus temperatures. As you go on heating the ice, what happens then? Suppose that you take just some ice cubes in this vessel. Okay, there is no change in our experimental process. What is our experiment? Just to pump the heat into the system, or just to heat the system. Now I am changing our system from liquid to ice. Okay, you are taking some ice cubes and you are dropping those ice cubes in this vessel. Okay, and you just started heating this ice. Okay, suppose that the temperature is below 0. So as you go on heating the system, what happens? It goes very near to 0. Okay, that means the temperature is increasing. See, it comes from minus 5 degrees to minus 4 degrees, minus 4 to minus 3 degrees Celsius. What is the meaning of this? Increasing of the temperature. Finally, you are going up to 0. If you further go on heating the system, what happens? From then onwards, you observe the liquefying process of the ice. So slowly all these ice cubes melt into the water, Here you see the water layer here. See, then what happens? Until it starts melting, you observe the rise in the temperature. Of the ice. But once it starts melting, what happens there? Since then, you do not notice any change in its temperature. Okay, temperature of the ice. Why? Because that temperature is its melting point. The temperature is its melting point. So here, as long as this entire ice is converted into the water, you will not notice any change in the temperature. So when do you notice the change in temperature? As you go on further heating the system, see, you will see the increase in the temperature of this water. Okay, when entire ice is converted into the water. Okay, whenever the phase change process, state change process completes, from then onwards you will see the rise in the temperature of the system. Until then, okay, you are going to see this water at the same temperature of the ice. Both you see here both the ice and water at the same temperature called melting point of the ice. Whenever the entire ice converts into the water, okay, but if you are still supplying the heat, then what happens from then onwards? Okay, it goes to 1 degree Celsius, 2 degrees Celsius, and so on. Okay, you will notice these things in this thermometer. See, you can only see the rise in the temperature until the phase change or the state change process just starts in. Then what happens? You will see suppose that this is Q, you are increasing this Q, you are pumping the heat into the system. See, initially you note the rise in the temperature here. See, rise in the temperature. See, whenever this is whenever you reach the point called melting point or boiling point, what is this temperature here? This particular T is melting point or boiling point. Okay, okay. Whenever you reach either the melting point or the boiling point, then what happens? See, you observe a flat straight line here. This straight line characterizes state change. Whenever the state change process completes, then what happens with the Q? Again the temperature of the system goes on increasing. Again the temperature of the system goes on increasing. See here, along this line you observe the mixed state. That means either water plus vapor or water plus ice along this line. This line, this horizontal line, characterizes the state change. Okay, this is what the magic behind the boiling and melting process of our prominent substance called water. Okay, so that's why we give some special names for one particular temperature called boiling point or melting point. So what is the special about those points? Whenever the system temperature of the system reaches to that point, okay, from then on we do not observe any change in the temperature. Okay, that's why that particular temperature called boiling point or melting point or something special. Okay, see, you are going to observe the system at that particular temperature for some long time. Okay, until the entire system changes from one state to another state. See, in the process of heating you are seeing so many temperatures, but one particular temperature you are naming. What is that? You are naming that one particular temperature as a boiling point and another particular temperature as a melting point. Why we are naming like this? Why? Because those temperatures are very special. Whenever the system reaches to those temperatures, the temperature of the system does not fall or rise, that means remains same as long as the state change process completes. Okay, here also you may make the same statement. As long as the process of state change takes place, the temperature of the system remains constant. You can make the same statements in this process also, that means liquefaction of the ice into water. Okay, these are the very important points we have to remember. So there is a great physics or the great magic behind the boiling and melting of the substances. Okay, let us recall what we have done so far. See here, one thing is, until the phase transformation starts, okay, the temperature of the system rises. Once the state's transformation begins, the temperature of the system, okay, will be the same. That means the temperature of the system will be constant. Okay, once the entire phase transformation is over, then what happens? Again we observe the rise in temperature with the heat pumped into the system. Okay, again the temperature rises with the heat. Okay, this happens both in the process of converting water into water vapor and ice into water. Okay, thank you.